Hi, let's revisit those two examples once again, and let's see. I want to just justify what we did. I feel that I didn't justify it enough, so let me justify it again. So, one example was every student, the previous two videos, every student in this class has taken OS. So this is one example, and for this example I told you that the right answer is for all x, s of x implies O of x, right, where x is set of all people in the world, right? And then here I told you that this is the right answer for this, and for all x, s of x and O of x, I told you that this is not the right one. I know, and then actually I didn't justify it well. I was thinking that maybe you must still be having some doubt in this. So how to answer such questions, how to be confident is just see this one. Now when we are talking about the set of all people in the world, it means our domain of disclosure is not the class, just the classroom. See, let us say this is the classroom, okay? This is the classroom and this is set of all people in the world. And this is whatever dots I put here, let us say they are all students, and whatever dots I put here, they are all set of all people in the world, okay? Now the problem here is, assume that all the students in the class have actually taken operating system course, which means everyone who is present in the class has taken the operating system, and we don't care about the people who are not present in the class. They might have taken operating system or they might not have taken operating system. I don't care about them, but just assume that in this for one case everyone in this class has taken operating system. Then what should happen to this statement? The statement should actually become true. Is it really happening? Now which one of these two is going to see that the statement gives a true value when everyone in the class has taken operating system? Now let's examine this one, right? Now when will this one will be true? Since you have for all, when will this for all statement will be true? When for every value of x, which means for every dot you see, either the dot is present inside or present outside, if you substitute in this statement s of x implies O of x, if you substitute in this statement, if for every value dot there, if this statement gives the truth value, then this entire statement will become true, isn't it? Now let's see if it happens or not, given the case that everyone in the class have taken the operating system course. Now where can we take the dots from? We can either take the dots from outside the classroom or inside the classroom, which means we can take a person who is not a student also, isn't it? So let's first consider the case where s of x is false. Now what does it mean? If s of x is false, it means the x is not a student. The person whom we are talking about is not a student, right? If he is not a student, it means that he is present outside the classroom. Now what should we do with him? We should not care about him. Therefore, our design should be in such a way that if the person is not a student, then it should not affect our result, isn't it? Therefore, if you observe this, if this one is false, the truth value of the implication is always true. The reason is, if you see the implication, let us say A and B, A implies B. I hope you remember this. True, 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 false, false, true, false, false. This is true, this is false, this is true, this is true. It is important. See this. Whenever this A is false, A implies B is true. Therefore, for all the people who are outside the classroom, for all of them, this value will become true. Now, what is the remaining case? What about the students inside the classroom? Now, when we go into the classroom, then s of x is true, which means we are either talking about these two cases. Now if everyone has taken the operating system course, then this will happen, isn't it? And therefore this will happen. Got it? So by this statement, what has happened is we have ignored completely about the students or the people outside the classroom, and we have only considered the case where will be false only when someone in the classroom has not taken the course, and will be true only when someone in the when all the students in the classroom has taken the course. Got it? So when all the students in the class have taken the course, whatever value you take for x inside that world, you will always get a truth value, right? Now let us assume that someone in the class has not taken the course. Let us say there is a student x1 somewhere in the classroom and he has not taken operating system course. Then what happens is, for the student x1, when you substitute s of x1, he is a student and therefore it becomes true, but then he has not taken the course, therefore it becomes false. Now true and false, what does it become? False. Therefore even for one value of x, if this statement is false, this entire thing is going to be false, and therefore this statement is going to be false, which means we are in the right direction, isn't it? If someone in the class has not taken operating system, then definitely this statement has to be false, and it happened. Got it? Now what is wrong with this one? Why can't we use it? Just see that for all x, okay, s of x and o of x. Now let us say everyone in the classroom has taken the operating system course. Then what is that we are supposed to get? Truth value, isn't it? Now this one will give the truth value when for every value of x, these two are true, isn't it? Now let's take an example where not taking an example. Let's see what happens when we consider a person who is not in the class. Just the simple thing. See, again, try to follow it clearly. What I am trying to say is, everyone in the classroom has taken the operating system course. Therefore, what is that we are supposed to get? True value. Now let me see whether this one is giving the true value or not. Got it? Now this one is, domain is all the people in the world. We are talking about everyone. So for everyone we have to check this. Now if I take anyone in the classroom and if I substitute here, then definitely student of x, since he is in the classroom is a student, therefore that person is student, it is going to be true. And since everyone in the classroom has taken the operating system, it is going to be true. Therefore true and true is going to be true. Therefore for all the students inside the class, it is going to give us truth value. But the problem comes when we have written for all and the domain is even including people outside the classroom. Now if you take a person outside the classroom and if you try to substitute in s of x, if you try to check whether he is a student or not, outside the classroom he is not a student, which means this one will become false. Then irrespective of whether he has taken operating system course or not, this entire thing is going to be false, which means for every person outside the classroom this entire thing is going to be false. And since for all is given here, if at least if you are able to find one false value, this entire thing will become false. So what I mean to say is, even when everyone in the class has taken the operating system course, this statement is giving us a false value. In fact, whatever statement you design for this given statement has to give us a true value, but it is giving false value. Got it? That is why this is not allowed and this is fine. Now did you understand the reason why implication is designed this way? The reason why it is designed this way is, we want to apply the condition only for a part of the domain, and if a value falls outside that part, we don't want to think about it or we don't want to bother about it. In this case, we want to worry about only the people inside the classroom. That is why, see this, these two are giving true or false. Only for the students inside the class, if something happens, then we are going to give it true. If it doesn't happen, then it is going to give them false. But about the students who are present outside our domain of concern, in this case the classroom, we should not bother at all. That is why when they are outside the classroom, we are not actually letting them affect the answer. Got it? Okay, that is why it is that way. And now let's see the next example. In the next example, I have given this. Some student in this class has taken operating system, right? And for this I explained like this: there exists x such that s of x and o of x. I told you that this is the answer, and in fact here x is same, all the people in the world, right? All the people in the world. Now I told you that this is wrong for all x. No, I told you that the other one is wrong. What is it? You might feel that there exists x such that s of x implies o of x, right? Now why do you think that this one is right, and why do you think that this one is wrong? Again, take the same example, and so let's see this. Now assume that someone in the classroom has taken operating system. Let us say the person is x1. Now what happens to this statement? So this statement is going to see that there exists x, s of x. So first of all, this statement will see that all the values who are not in the classroom will not give us a truth value. So if you see this, if you try to take a person who is not in the classroom, and if you substitute that person in s of x, it will give us false, which means for everyone outside the classroom, outside this entire thing is going to give us false, 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 which means everything is going to give false. Therefore, for this value to be true, someone inside the classroom has to take operating system. If someone outside the classroom has taken the operating system, it is not going to affect this answer. Got it? For all the people outside the classroom, it is just giving us false. That is what we wanted. And now when we go into the classroom, right, this one will become true. Now if this entire thing has to become true, then at least someone has to take it. Therefore, if at least there is some person who has taken operating system course, this one will become true, and this entire thing will become true. And therefore, even for one value, if this entire thing becomes true, then this entire thing will become true. And so some student in the class has taken the operating system will become true when someone has actually taken the operating system course. Are you getting this? Now the problem with the other one, this statement, is whenever I consider a person who is not in the classroom, then this will become false. So whenever this becomes false, I told you that this entire thing will become true, isn't it? Which means we are able to find out some value of x for which this entire thing is true, and so it will directly say that yes, it is true, even without getting inside the classroom, even without knowing anything about what people in the classroom are doing, whether they have taken operating system or not, even without verifying that condition, this will always be true. Which means whether someone in the classroom has taken operating system or not, without any regard, this statement will always be true. When you consider about this, this kind of domain, every person in the world, this statement will always be true irrespective of what happens here. But then this statement will be true only when someone inside the classroom has taken the operating system course. If that person is outside the classroom, that will never become true, or he will never affect the result. The person who is outside the classroom will never affect the result, because this itself will become false. When this one has become false, this entire thing has become false. Therefore, for every person outside the classroom, this entire thing will stay false. Only when we enter the classroom, then this one will become true, But still this entire thing will become true only when someone has taken a operating system course. Now if someone inside the classroom has taken the operating system, then it will become true, and since we are able to find someone who has taken the operating system, this entire thing will become true and this statement will become true, right? I hope that you understood this. Otherwise you please watch this video over and again and just see that you understand this example perfectly well. Otherwise what happens is, see, every other question in this logic can be easily answered. Only place where I see people getting confused is between these two representations and these two representations. If you can understand this well, you can assume that you'll definitely be able to get that 1 or 2 marks from this subject. And in fact, these are so simple questions that you can look at the options and you can pick them. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.